Welcome to another coding tutorial, and in today's video, I'm going to show you how to make a binary piano. This tutorial is a great exercise if you want to get started with sound in p5.js. We'll be using two objects in the p5 sound library. The first one is the p5 oscillator, and the second one is the p5 envelope to control the sound. And before we get started, I want to credit this piece by Tim Holman, which I took an inspiration for this tutorial from, and also this video, which he credited as his inspiration for his piece, and I will link everything down below. Alright, so what is binary in a binary piano? What we talk about here is a binary number, which is a number that is either a 0 or 1, and it is in a base 2 numbering system because there are only two numbers. And it is different from what we're familiar with, which is a base 10 numbering system, or a decimal numbering system that can be represented by 10 numbers from 0 to 9. But what is so special about a binary system? It is the language of computers. What I mean by that is, computers cannot actually understand the code that we write. They can only understand code that is written in a string of zeros and ones. Computers are built with lots of electronic parts, with switches that can be turning on and off. Code that is written in binary with zeros and ones, ons and offs, is much easier and simpler for computers to understand and process, and also takes up less space. But luckily, we don't have to write code in zeros and ones. We can write code the way that we write because a computer has a compiler that actually convert our code into machine code or executable code where a computer can then understand and process and execute. Now, how do we read a binary number? Let's take this number for an example. 11001. This is a 5-digit binary number. Each digit represents base 2 to the power of n, where n is the placement of the number, starting with 0 in the most right location and increases by 1 as it goes to the left. A binary number basically tells us whether we use that number or not, where 1 is a yes and 0 is a no. And once we do that, we just add the number up. So it's 16 plus 8 plus 0 plus 0 plus 1, which equals to 25 in the base 10 numbering system that we're familiar with. Our binary piano is essentially a 10-digit binary number that is incrementing by 1 over time. But how we're going to approach this is that we're actually going to increment a decimal number, and then we're going to convert that number into a binary number that is going to play a note every time a digit in a binary number is 1 and doesn't play a note when it is 0. Alright, so first we're going to write a function that converts from a decimal number to a binary number. So I consulted this website, Geeks for Geeks, to understand the different ways that we can do to convert from decimal to binary numbers. And in this website, they show us with 4 different approaches, but the approach I'm going to choose is this third one, using toString_of_2 method. So let's come down here. So the toString_of_2 method is a built-in JavaScript method available for a number objects that converts a numeric value, decimal number, to its binary representation as a string. And this is the syntax. And if you look at the function here, basically the value here is the decimal number, and this is how you're going to write it. val.toString_of_2, and it is going to return a binary representation of that number in a type string. Alright, so we're going to call this function decimal to binary. And I'm going to provide a parameter called val, and then we're going to return val.toString_of_2, right? And then how about we just print this out? Print decimal to binary, and how about we put in a value of 25, and it should return the exact same binary digit that we saw previously, which is 11001. Great. Now, how about I also show you, let me actually just define this as binary, decimal to binary of 25, and then I want to show you that the first thing is that binary.length is equals to 5, right? Because there are 5 numbers here. But type of binary it's in the type of a string. So it's one string with the length of 5. Alright, but what we want to do is that we actually want to create an array of size 10 because I want the binary piano to be a 10 binary digit number. So first, what we're going to do is we're going to tweak a little bit inside this function here. So first, how about I declare binary string as a variable and set it equals to this. All right, so this will return a string of size, whatever size this decimal value is, right? And then I'm going to declare another variable, an array called binary array, and it's going to start out as an empty array. Then I'm going to actually declare a third variable called length, and this is going to be the length of the binary piano, which is 10. Actually, let's define a variable called num, set it to 10. And so it's going to be num minus binary string of dot length. Right, so the reason that I'm doing this is because let's say that this value is 11001, but if the size of this string is less than the size of 10, I want to put these numbers towards the end of the array, and I want to fill up the space with zeros. So this is just to check what is the length of the binary string and then how many of the spaces need to be filled with 0. So I'm going to write a for loop that goes between 0 and num, which is 10, right? And then I'm going to write a conditional statement that says if I is less than length, then I want to fill the binary array with 0. Else, I want to fill this binary array with this, right? But right now it is one string with a length of 5, but actually I want it to be separated. I want to parse it into each of these separate numbers. So I can actually use a built-in method called char@. So what I need to do is I need to put in the string, so binary string dot char@, and then the index I. And this way it will separate each of the numbers here for me. But it is not the index I, right? It has to be I minus length, because we go from I equals to 0 to I less than num, which is less than 10. But the binary string is only of the length that is less than, in this case, than 10. So I minus length. And then we want to return binary array. So let's try this. So in here, we don't need this anymore. So let's try to print it out. All right, so now we have, you see, the last 5 digits here are 11001, and then the first 5 is 00000. So we can start with the number 0. And so this is 10, and then if the value, the decimal is 0, and then we put in DC in here. So 0 is, it's all 0, right? 1, 2, and so on. And then now if we started it at 0 and we want to increment it by 1, what we can do is, the way that I'm going to approach this is I'm actually going to use frameCount. So how about we copy this into the draw function, and then let me print out frameCount. So this is counting the number of frames that are being drawn. So because right now the frame rate is 60 frames per second, so as you can see here, it goes from 1 and then go all the way down, and then so on and so on. So what we can do is, because it is the frame count of 60 frames per second, so in each second there are a total of 60 frames. So what we can do is we can use an expression called modulo, and then we put in 60 here, and what this does is that it divides frame count by 60, and it returns the remainder that is coming from this division. So by doing this, we now get the values that is between 1 and 60, right? Because the remainder, actually not 60, 59, because the remainder between these divisions is going to be either between 1 or 59, because if it is 60, then the remainder is 0. And what we can do now is what if we set it as a condition? So frameCount mod 60 is equals to 0. So every time the remainder is 0. False, true, true, true. And it happens every second, right? Because there are a total of 60 frames per second. And this, we can use this as a condition to actually increment the value of the decimal number. So if we want it to be a little bit faster, we can do mod 30. So that would be every half a second. So if frameCount mod 60 is equals to 0, then what we want to do is we want to increment this decimal number by 1. And now how about I print the decimal number? 0, 1, 2, and you see it's every second, right? 4, 5, and we can change this. Let's do by 30. 3, 4, 5, 6, 7, 8, 9, 10. So it's faster. All right, so that's how we're gonna increment the decimal number. What we have now is that we have a way to convert from a decimal number to a binary number, and also we know how to increment the decimal number over time. Next, what I want to do is that I want to write a class, and I'm gonna call this class blocks, and blocks basically are going to be a total of 10 block objects that is going to be displaying 10 binary digits on the sketch. So let's come to this arrow here, click the plus sign, and then click create file. I'm going to call this file block.js, and then let's go to index.html first because we want to integrate this file into the program. So you want to copy and paste this line of code, change the name here to the name of your file. In my case, it's block.js, and that's how you integrate a new JavaScript file into the program. Let's go to block.js. I'm going to call this class also block, and then inside the constructor function, we basically need two sets of things. The first one, I'm going to call it binary, which is for the binary number. And then we're going to have a set of variables that will indicate the location of the blocks. So this.x, this.y, this.width, W, right? And then this.h for height. X, Y, W, and H. And then let's write a method called display, and we're gonna draw a rectangle at this.x, this.y, this.width, and this.height. So let's start with this. We're gonna go back to sketch.js, and then I'm going to swap this, and then I'm going to create an array called blocks. Inside setup, I'm going to create a bunch of block objects. So let's use a for loop that goes from I equals to 0 to I less than num, right? Because it's going to be a 10-digit binary number. And then blocks array will be new block objects. So the number, we're going to start with zeros for all of them. And then the locations will be, how about we defined x0, y0, width and height here, and then inside setup. So let's set x0 to be equals to 0. I want it to start at the left side of the canvas. And then how about y0? Let's do it at height divided by 2. And then for width, we're going to do it based on the width size and then the number of blocks, which is 10. And then for height, let's just set it at 50 pixels. So here we're going to put in x0, and then x0 we need to add it by the increment that we want to separate each of the blocks by, right? So I times width, and then y0, width and height. And then down here, all right, so let's start by commenting this out first. And then we're going to use a for loop again. And we're going to call the display method. All right, so now we have a total of 10 blocks. Actually, the width, what we want, no, the height, the y here should be height divided by 2, and then subtract it by height h divided by 2, right? So let's put these in front. And the reason I want to do this is because I want it to be in the middle of these rectangles. All right, so this is exactly halfway of the canvas. Now, inside the display method, I actually want to write the numbers, right? So let's use the function called text, and we're gonna write the binary number at what location. Let's just start with this dot x and then this dot y. All right, and with the text, it is anchored at the bottom left corner. So what we want to do also is, actually first, we can use a method called text aligned, and basically instead of having it at the bottom left corner here, if we do center and center, I think it should center this piece. All right, so now the anchoring point is in the middle. But instead of putting it at this dot x and this dot y, I want it to be in the middle of the rectangle. So what we want to do is we want to put in this dot x plus this dot width divided by 2, and then this dot y plus this dot height divided by 2. All right, and then how about we change the size to be a bit bigger using the text size function. Let's put it at 30. Okay, that's a good start. So next, what we want to do is that we want to go back to sketch.js and actually increment the numbers. So now, binary is going to be a string of binary numbers based on the decimal value here. And so inside this for loop, what we want to do is that we actually want to set the binary number of each of these block objects to be equals to the value inside this array, right? So binary of I, and let's run. Yay! Okay, it's working. Perfect. Now, how about we also write another function that's called display decimal. I just want to display the decimal number. So text, and we want to display the value of DEC at what location. Let's put it at the same X location, but let's put it at maybe 150. Let's do text size to be a little bit smaller at 20. Then I'm going to call it at the end here, display decimal. Oh, and we want to change the text aligned to be left. Nope. Oh yeah, it's right. So 15, 16. What I want to do is also label it at with decimal. Perfect. Now let's add some sound. So we're going to be declaring a set of variables that are related to two objects inside the p5 sound library. The first one is the envelope object, and the second one is the oscillator object. And I go into the details of how these two objects work in a separate video, which I will link down below. First, let's start with an envelope object. So I'm going to call it this.env, and it's going to be set to a new p5 object inside the envelope class. And then we're going to be using two method inside here. The first one is set range, and then the second one is called set ADSR for attack, decay, sustain, and release. And so I also want to set these variables here. So the variables that we're going to set, there are a total of 6, and these are going to be a set of beginning, middle, and end volume and time it takes to get from one volume to another. So let's start with attack volume, which I'm going to set at 1, and then sustain volume is going to be set at 0.5 or 50% between the attack volume and the release volume, which I will set at 0. And then we can just put in attack volume in here and release volume in here. And then the other three are attack time, which is how it takes to get to the attack volume. Let's do 0.01. And then decay time. How about we do 0.1 for this? And then release time. Let's do this one at 0.01 as well. And then inside here, what we need is attack time, decay time, sustain volume, and then release time. To be consistent with my other tutorial, let's call this sustain ratio. I think I call it that because it's the ratio between these two volumes. All right, so this is how we are going to be setting the amplitude for each of the stages of sound. And then we're going to pass in this object into, as a parameter, as an argument into another sound object, which is going to be part of the oscillator class. So let's call it this.osc will be a new p5.oscillator object. And then actually inside this class, we can set the sound wave type, and the default type is a sine wave, but I actually want to change it to a triangle wave. So we can just put in this as an argument. And then we need to start the oscillator, and we want to set a frequency to a specific frequency, and we can just put in a value of the frequency in hertz. But what we can also do is we can use this method called MIDI to freq, where we provide a MIDI note, which is a number that corresponds to a particular note, and it is going to convert it to a specific frequency to that note. And what I want to do is actually I want to set this note as another variable, actually another parameter that we're going to put in here. And then we're going to set the amplitude to this envelope object that we have created here. Now what we want to do is that when do we want it to play? So how about we write a method called playNote, and we want it to play when this dot binary is equals to 1, a string of 1, right? Then to play it, we just do this dot env dot play. That's it. So now if we come here, oh, what I want to do also is I want to set the color to a different color when it plays. So how about we set it to the color red, and then else, then we set it back to the color white, and we will start it as white. Oh, we need to also set note here. And inside display here, we're going to fill the rectangle with this .c, but for the text, we're going to fill it with black. Okay, I think this should work. So if we go back, we need to do two things. The first thing is inside this line of code here where we created the objects, we need to add the note. So I'm going to put in the MIDI note of 60, which is a C. So all the notes are going to be the same for now, which is fine. And then inside here, we also need to call blocks of play note, right? Okay, let's try it. Set range is what? Set range is not defined. Oh, it's not equals, it's this.env dot set range and this.env dot set ADSR. Oops. This.freq. Oh, so this has to be this.osc and same as this. Oops. All right. It works, but because it's only playing just one note, the middle C, you can only hear one thing. So how about we add some more notes? So MIDI notes, and then let's just comment some of these a little bit. So MIDI note, I want it to be, first I want the starting MIDI to be a value of 48, and then I want to add the starting MIDI here of 48 to an array of these notes. So these are all the white key on the piano. Actually, I want it to be an octave higher. So let's start at 60. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we need 15 also, actually. We need 10. Okay. And then instead of 60 here, we want to do starting MIDI plus notes of I. Actually, this has to be 16 for it to be a white key. It is kind of slow, so how about we change this to 10? A little bit too fast. Let's do 15. Alright, so the basic of this code is now working, which is great. So how about now, let's add some colors, let's add some buttons to play and pause the sound. So first what I want to do is that I actually want to add a little bit of margin to my blocks. So I'm going to set margin, actually I'm going to call it border, and I'm going to set it to 10. And so now the width is going to be relative to width plus border times 2, right? And so this x0 will be from 0 plus one side of the border. Let's try it. Oh, it goes all the way out. Oh, it has to be subtract. All right, okay. And this way you can change the border to whatever you want. Next, I'm going to put in margin, which is going to be the space in between each of the blocks. Let's do 3. And with this, we also want to add margin to x0 here. But then the width now is going to be smaller. So it's going to be width minus margin. But the spacing will still be width. So, all right. And you can change this to whatever you want as well. But I'm gonna keep it at, how about 5? Okay, next I want to add a button that will allow us to play and to pause the sound. We're gonna use the create button function here to create a button, and what we need is we need to declare a button, set it to this function here, create button, and then inside here we can label it play and pause, set the position, and we can set the size as well. And then this one is when we call a specific function when we press the mouse on the button. All right, so let's copy and paste this. And I'm actually going to create a different function called GUI for graphical user interface. And then I'm going to call this function inside here so that it's a little bit cleaner. And then inside here, we're going to create a button, and I'm going to call it play/pause. And the position, I want it to be actually off the screen. So I'm going to put it at the very bottom at 0, height plus 10. And then I'm going to comment this out first just to show you that it's here, doesn't do anything yet. And so we want to use this function here, mouse pressed, and then we're going to write a new function. Let's call it play sound. How about that? And then at the end here, we're going to write a function that's called play sound. And I'm going to create a variable called play. And play is going to be a Boolean variable that is going to be switching back and forth between true or false. And it will start with false. And every time the button is clicked or is pressed, then play will be set to the opposite of play, and we can use this exclamation point to get that value. So play equals not play. And then inside here, we need to update this conditional statement that says if play is true, then we will increment this, and else then we will not increment the decimal value. So start at 0, and then we play, we pause. But you can hear that when we pause, we still play a sound. So we need to also actually update the block class here, inside here. So if this.binary equals to 1 and play is true, then we want to play the sound and also keep this color here. But else if this.binary is also equals to 1, but play now is equals to false, then what we want to do is we want to just change the color to this color, but do not play the sound anymore. Great. Okay. Now I don't want it to be these colors, so let's change those colors. So how about I change this to a nice pink color, and then I want the stroke to be white, and I actually want to set this color here to be this variable. I'm gonna call it BG for background for now, and then don't worry, I will go back and set it right now. So let's go to sketch.js. I'm gonna set BG to a value of 50, so it's going to be a dark gray color, and inside background here I'm going to set it to this color as well. And then for decimal here, we also want the fill should be the same color now, so let's try it. All right, I don't want the stroke here, so how about we put in no stroke. That's nice. All right, I'm going to stop here, but this is how we can incorporate a bunch of different things together in one sketch, and I think it introduces you to the basic of the few sound objects inside the sound library class. So I hope that you have fun and give this one a try.